Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are in the middle of enabling our game to sort of work in 3D. Not really for any particular 3D reasons because it is a 2D game, but after going down the road of sprite sorting, I just decided that it wouldn't really have the throughput that I was looking for, even though it was conceptually nice, and so I wanted to find a way to use the GPU more effectively for more sort of heavy primitive counts and that sort of thing that I thought we might want. So I decided, even though I had not really wanted to go down that road particularly much because I was trying to keep things focused on 2D, I decided to switch to 3D just so we could have that. And so basically what we're doing right now is just finishing that switch. I wanted to talk a little bit something that I did last week because I realized after the fact that we probably don't really need to worry about it as much as I thought we were going to have to worry about it. Because I was kind of thinking about things in a way that I probably didn't really need to, and I'll talk a little bit about that in a second. But let me first explain what I did at the end of the stream last time. Today is day 366, so you're going to want to grab that day 365 out of the source archive if you want to follow along with what I'm doing. That is the code to start with. Let me go ahead and show you what I'm talking about. So here is the build from last week, and you can kind of see here that what I'm doing is I'm just drawing these tree sprites so that they're always facing the camera. And I did that kind of at the end of last stream, and I wanted to talk about a little bit of that just in a second here. So let me give you a little bit of a explanation of what I did, because I kind of threw it in at the end of last week's stream just to say, oh, well, we could do it this way, and then I never really talked about it. So let me just talk about that really briefly, what I threw in there, because you notice I didn't really even do any math to do it. I didn't have to write on the blackboard. I just kind of typed it in 10 seconds, and it worked fine. So how did I do that? What was that? And why was it so easy or simple to do? So let me go ahead and get some space here on the drawing board. So here's day 366. And so this is camera facing cards. So the deal with this is the camera-facing cards are sort of what we need to do in order for sprites not to lie down flat. Now, if you take a look at, for example, the ground right now is lying down flat, right? You can kind of see that, those, even I don't have a texture on them at the moment, so it's hard to maybe relate them back to the trees per se, but those are just filled areas that could be filled with a texture. And they, form a flat kind of plane. When the camera moves around, that plane is still the plane, right? And you can kind of see that the plane is behaving in 3D as it normally would, as if it was sort of a flat sheet. And the problem, if we do that, obviously with the sprites that we have, and I'll go ahead and just actually make this happen here so you can see. So if I don't allow any of the sprites to stand upright, then you can see what happens to the trees in this case, right? They're just kind of stuck flat on the ground. And you can see the Z fighting here. All of this stuff is stacked directly on top of each other. So you end up with the precision of the Z buffer, the iterator, sort of giving you random results as to who's in front of whom. And so if we look here, you can kind of see what happens if everything lies down, right? If I want these trees to appear, if this is the view of the game we're going to typically take, and I want these trees to appear as they were probably intended by the artist, I don't want them lying down flat. So I want to have a way of having them appear as if the artist, exactly the way the artist drew them in a flat camera-facing way, right? And so I want them to always be aligned with the screen. And you can see it leads to some odd effects as I kind of, flip around here, because the trees look like they're always turning to face us, because that's exactly what they are doing. We only have one view of the sprite, so no matter where we look, we're always going to see that one view. But other than that, it produces a very nice 3D version of this sprite, because you can see it's always providing the right aspect ratio and the right alignment with the screen to give us that sprite's actual image, to make that sprite's image look correct, right? So the question here is, how do I, how did I do that? And the answer is just that if I want to draw a camera-facing card, well, what do I know about my projection, right? Well, my projection matrix is a thing that's going to take, right? I've got a camera here. And, I've got an X and a Z and a Y of the camera. And the camera is, looking out into the world, right? And there's stuff out in the world, maybe there's a cube sitting out here and I'm viewing it, right? And what we will know about this camera is that anything along the Z-axis, right, is going to determine a certain depth information, and it's going to affect our perspective divide such that the further back you are, the further you are in negative Z relative to where the camera is. Remember, this is in camera space. Here I'm talking about things on the camera's axes. So if I go along Z, the further I go negative Z, the smaller things get. So things that are back here are going to appear very small. Things that are up here are going to appear big. And so the perspective distortion is happening along that Z-axis. However, if you think about what happens to the XY plane, so the plane that the X and Y axes are in, everything in one XY plane has no varying Z component, right? That's the definition of the XY plane in this case, is that the Z component is the same everywhere. And I could move that plane anywhere I want along the Z-axis, right? And as long as I'm still talking about a plane aligned with the X and Y axes, everything in the plane has the same Z coordinate. That means there's no distortion as to the elongation of one part of something in the plane versus another. This part, right, of the plane and this part of the plane are going to appear exactly the same distance away from the viewer. Okay, it's not going to get elongated in some weird way where if I was talking about a plane that was, say, not that way, like a plane that was sort of this way, right, then this part would appear much further away than this part, which would appear closer, right? And so if I were to draw something on that non-XY plane, it would warp, right? I would get, if I was looking at it, here's my screen, and I'm looking at these things, something aligned to the XY plane looks like that. It looks like a sprite card that's facing the camera, which is what we would want. Something that's drawn on this plane would look more like this, right? This back part would get shrunk down, because it's further away in Z. So what that means is if we want to draw things which retained their rectangular right angle nature when pushed through the perspective projection, it's actually very simple. We just need to keep them on the XY plane, right? And more specifically, any XY plane. It doesn't matter what the Z can be. The Z can be anything as long as it's the same on all of them, right? So now comes the question, how do we produce points that are on an XY plane relative to the camera, right? Because remember, we're sending down these points in world space, right? We're sending down these things in the same space as everything else, including how the camera specified. That world space might be some other thing that's like over here, right? And has different axes. These are the camera axes, but the world axes where everything else is specified in terms of, and the origin of the world and everything else, this is the camera's position, right? These could be totally different. They don't have to coincide in any way. The axes don't have to point in any similarly, the position can be different, whatever, right? Even the scale could be different if we wanted. So the question becomes, if we're submitting things in world space, how do we produce things that are on an XY plane in camera space, right? Because we don't know what the XY axes are in that space in world space, right? We need to be able to talk about XY planes in world space that are XY planes in the camera space. So the X and Y axis of the world don't help us here, right? They don't tell us the information. But lucky for us, we know the camera's XY axes because we used that. We passed the X and Y axes down to create our camera transform in the first place. So what that means is we still have the camera X and Y axis lying around. So all we have to do if we want a sprite card to be facing the camera properly is we just have to go ahead and make sure that the axes we use to construct the sprite are the X and Y axes of the camera object itself. Those two axes will tell us exactly what a constant XY plane would look like in world space because they are the two spanning axes of that space, right? The z-axis of the camera is the thing that tells us the direction along which we cannot move if we want our sprite to remain in the same XY plane. Okay. So what I did is oops, that's not what I want. What I did is exactly what you would expect. You can see here I took the x-axis and the y-axis of the entry that I was trying to create, and I just assigned to those the size that we wanted the sprite to be in x, and I used the camera's x-axis as the axis for that, and I took the size we wanted in y, and I used the camera's y-axis for that. And that's exactly what we want in order to create the sort of span for the sprite in camera space, basically, rather than world space. Even though we have to express it in world space, we can do that by just using the camera's x and y axes as defined in world space, right? That's what these are. This is the camera's x-axis defined in world space, the camera's y-axis defined in world space. So we use those and we get exactly what we want, right? And so when we use those, we get our sprites sort of standing up exactly like we want them to, always facing the camera. So that's exactly what we want to do there. The problem here is that we need a little more than that. So if you imagine this might be, and this is probably a little bit too steep. So I mean, or a little not steep enough. If you imagine the game wants to look roughly like this, and this is like the dude kind of coming around here, if we want the game to look roughly that perspective, then the question is, well, okay, what exactly are we going to do if the camera is at that perspective? What are we going to do about sorting these sprites into the world? Because, like I said, we kind of want them to stick sort of layer together. And it might be that this is not a sufficient amount of standing up for the sprites. Now it might be. I don't really know. It might be enough. But what I want to do is first add a way that we can look at how much they are standing up, and then if we want to and we need to, we can go in and try to figure out a way to add some more. Sort of puff them out further, if that makes sense. The way that we were planning on doing it before, only I realized sort of after doing this that we probably want to start with this construction rather than this construction because we do probably want them to always do x and y axis facing like this. So that's sort of a separate thing. Anyway, so ignoring this part for a second and just focusing on this part, what I want to do here is just introduce that concept of a debug camera. We've used this in the past in Handmade Hero. We had a debug camera, but we don't really have support for the rotation in it now. Only for we sort of had it for zooming out is the thing we had it for. So if you take a look at this, the way we have it now, we can move the camera around, but there's only one concept of where the camera is. What that means is that these sprites, right, are always facing the actual camera I'm using to view the world, even though what I really want in this, ability to rotate the world around, this is not, the game will not let you do that, right? So the reason I put this camera in is so that I can use it for debug. In order to use it for debug, I need these sprite cards to remain fixed at their locations and orientations in the world while I rotate around, because my rotating around like that is the thing I'm going to use to inspect them for debugging. So what that means is, again, we need that concept of two sort of separate things. We need the concept of a sort of the debug camera and the actual game camera, and we need to be able to switch between those, right? And so if you take a look at render group, and we've got this sort of notion in render group of, here's some some information about the camera, and then here's the projection matrix. This camera information here we're using to generate our sprites, and so what we really want to do, I think, is say that this projection matrix here maybe is going to be the thing that the camera that's actually used in the renderer, but these here can be set separately, so they can always be set to the game's camera, and the debug camera can be something else that overrides this, right? So if we were to do something like that, you can see in here, we sort of have this set camera transform situation, and you can see how it's getting set there. What I want to do here, perhaps, is introduce to the set camera transform call, and I don't know, this might be a little bit sort of janky at the moment, so we'll see how it goes, and we'll adjust as necessary if we need something a little bit fancier. But if I were to go ahead here and just adjust this so that instead of taking a Boolean for ortho, I have like a camera transform flag idea. And so I could do like camera is ortho is one of them, maybe orthographic. Camera is debug, could be another one. And so now in here, instead of taking that ortho idea, I'm going to take flags. And then we can say, well, OK, if it's ortho is just if the flags and camera is orthographic is set, then it'll be ortho. And I can say that it's a debug camera if it's got is debug set. And then when we come through here, I can choose to not update certain pieces of information if it's a debug camera. So I can say if it's debug, maybe don't set these things that I'm using for sprite generation, because I want the sprites to be generated as if there wasn't any of that. All right, so let's go ahead and jump into the world mode where this is being set. And we can see the set camera transform call happening here. And you can see that it's going along and doing this Z rotation thing. So what I want to do here is I want to pass, and I could, if I wanted to, do a thing here where I do camera is perspective. I suppose I could do something like that, even though there's really not much need for it. But if I wanted to, I could. I don't think that's necessary. I was going to say that's just a little more information, but it's just not necessary. So here we can do two set camera transforms, right? And what I'll do is I'll do one that's the actual camera and one that is debug, like so. And what I'll do is in the one where we do set camera transform, for the regular one, I'm going to forego the debug camera orbit, debug camera pitch stuff, right? So basically what I'll do is say, OK, here's the debug one. I don't know what camera offset Z. It's world mode camera offset. So I guess what I want to do here is say, I guess what I really want to do here is say that the camera offset in this case is actually, I want to add to the Z, so I guess I could just do, camera offset plus D3 and just stick this in the Z component, right? All right, and so here, let me go ahead and put that down here because this is actually where we want it. So what I want to do here is I'm going to go ahead and set camera orbit and camera pitch as opposed to debug camera orbit and debug camera pitch. And then we'll have a camera dolly there as well. So we can essentially have all of this stuff set up as we want. And then we can do this twice, one with debug and one without. So if I go up here and I add those in, what I can do for now is just set those directly, because right now we don't actually need them to be anything other than prescribed values. And let's go ahead and put those in there. So if I have these as prescribed values, I don't need the dolly at this point, and the orbit and the pitch. I probably will never use the orbit in the actual game, so it's really just the pitch. And the pitch is going to be, I guess, probably something, like I said, fairly steep. I'm not sure exactly what it'll be. We'll have to play with it. But yeah, something. Ooh. That's not exactly what I expected to see. I think I did something slightly wrong there. Oh, right. I did do something slightly wrong there. So, I should probably also have some way of switching between these. Now that I think about it, I'm not sure exactly how I should do that, because I need to be able to flip back and forth. So there effectively needs to be something here, right? And I'd like that something to be pretty quick. I guess I could use maybe the right mouse button for the moment or something like this, and C, I don't know. But I will need something here where it's like, use debug camera. There we go. And I want some way to switch really quickly between those two. Let's take a look here. I don't know if we have any useful keys, really. Yeah, not so much. I could assign it to a debug variable later, although a debug variable is a little cumbersome to go up and set. So I don't know that that's really the best choice there. But what I can do now is just say if input is down, input mouse buttons for mouse button right. Then we will do build mode, use debug camera, and we're good. So this is the actual game camera here, and my rotating around doesn't do anything. If I switch to the right mouse button, oh whoops, I need that to be went down because I don't want to constantly toggle between them. I feel like we had one, something like that. Oh, was pressed. Here we go. So if I toggle between them now, I can switch between these two. So here's the game camera, and all the sprites are facing properly towards the camera itself. If I switch to the debug camera, now when I rotate around, I can sort of see how everything is aligned, right? And the thing that concerns me, this is what I was trying to get to before, is just that if you take a look at how these guys are sort of sloped there, you can see how they are really kind of steeply angled. They cross over into the next cell boundary really early. And I just worry about that as being potentially too much. You know, the thing is, I guess, and I don't really know, but I guess it's okay. Well, I don't know. I don't know that it is because, for example, if we were to have something in this location here that was, sticking up straight, like, if this cube were kind of coming up here, this would interpenetrate and that would be bad. And so I feel like from back here, which is the game camera, right? So from back here, I want it to look like this, but I want ways of doing that that will push it more up into its own square, right? So I want it to come closer to me, but I need it to still retain its shape properly. That's the trick, right? And, I guess there's ways I could maybe do that with just modifying what the z-coordinate actually is going to be, because I do have opportunities for doing that, I suppose, in ways that would make it so that the z-coordinate was different. But, yeah, I don't know that I want to go that route, right? I guess what I'm saying is, so the z buffer is going to operate on the information that we tell it to, right? We are providing the z coordinates to work with for the z buffer, and we could choose, if we wanted to provide different information for the z buffer than the actual z coordinates we're using to draw the world, right? And they would, that would essentially give us the ability to prevent things from intersecting with each other in those cases. I don't know if we want to do that or if we want to do something that pulls these things forward in a way that preserves their perspective. It's kind of a tough call. But to be honest, I do think that I'm leaning a little towards just using an additional value there, because it does seem like that would be much simpler. If we have the world looking like this, and we simply change the z values so that they increase much more gradually than they would given the actual z values here, so that you get different results. I feel like that might be the easiest solution. Because I guess there's, I can't think of any real reason to do sort of the more advanced math. We did the math out there for doing the intersection and bringing figuring out a way to preserve the apparent size of the sprite. But, do we really want to bother doing that math on every sprite all the time when we could just fake the z-coordinate by passing down different z-coordinates at the corners than the actual z-coordinates we're using to draw? Because that's one of the things that we can do, with modern programmable GPUs, is we don't have to confine ourselves to just using z as the z that we use for projection doesn't have to be the z that we use for the depth buffer. We can use a different value entirely for the depth buffer, and the card doesn't care. It just needs to know where to get it from. It doesn't have to be tied specifically to where we are placing the sprite in the world. So that does seem kind of compelling, and maybe that's a good way to go. I kind of like that. That seems pretty good to me. So so let's maybe take that a little step further. What I'd like to do now is say, okay, those sprite cards could just be the way that we do them, exactly like that. And we still have to deal with the alpha issue, but otherwise the sprites look like they should look, and I can play the game the way that I want to play it at roughly the perspective that I want. I would also mention that this is not probably the perspective that I want. I want it to be even steeper than that. I was looking for a very steep angle in the game, probably something more like this, right? Maybe even more. I don't know. It's hard to say, but a very steep angle. And so, at that point, you can really see too. These sprites are just are only barely, only barely rising up out of their area. But this is more what I wanted. I really didn't want very much perspective there. That was not my intent. I just needed I wanted a little bit of perspective. Since we were going to have the ability to do that, I want maybe just a little bit of that. And so as you kind of move through the world, there is just that little tiniest bit. We could also, I suppose, go for one that's directly flat on. But of course, again, in that situation, we do have to think about how we're going to stand those sprites up. But maybe that answer to how we're standing those sprites up in that case would be that we would just, again, fake that z coordinate. So I don't know. The other thing is, too, we may find as we go a little further down that it does look a little nicer to have that sort of perspective be a little bit different like it is here. I'm not entirely certain. That's a good question. And so, I guess it remains to be seen. Because the game is sort of played in a tile-based fashion, I feel like that gives us some opportunities to maybe have a more oblique perspective like this, because it means that you're not so concerned about lining things up precisely in 3D, because the tiles, kind of do that for you. And make it easier for you to do things in 3 dimensions that would ordinarily be a lot harder to do. So I feel like that might be that might be all we really need to do there. I don't know. It's a good question. The other thing, though, that I would point out is that we do want to have sort of dungeony walls here, so it wouldn't just be trees. And so, like I said, we kind of need to take a look at sort of the next step here, which is to sort of get some 3D blocks in there. All right, so let's postpone thinking about that Z for a little bit, because we're going to need to pop over to the OpenGL layer and do a bunch of stuff on that. Maybe that'll be next weekend, but we're going to have to be able to load shaders and be able to set what we want our depth stuff to be and that sort of stuff. So we have work we're going to have to do there where, it's going to be a little bit more complicated. But, and we also need to do the multi-sample anti-aliasing stuff. So we just have a bunch of literally nothing but OpenGL busy work to do over there to just basically bring the GPU in line with the stuff that we want to be able to do in terms of setting up the rendering, right? So we do have to pop over there and do that at some point soon, but I don't know that I want to do that quite yet, because I would like to also now start passing down some more 3D-like primitives, and I think that, for the most part, will involve us having to set some or provide some other options in our render pass. So the problem here is we have to think a little bit about how we're submitting things to the renderer in the first place. Because we were doing things as a simple 2D game before, we really just submitted things as sprites, because that is what we primarily conceptualize our world to be, is, hey, we've got these 2D images and they're on the screen somewhere, and that's, whatever that is. Great. But what I'd like to be able to do is I'd like to be able to, in addition to sprites, so I've got things like that tree are a rectangle that's drawn essentially with 2 triangles, right? One here and one here. And that is how we're drawing individual sprites. This alpha knocks out this area. I would also like the ability to draw basically cubes. So I would like for those things on the ground, to basically be cubes that kind of look like this to the viewer, right? Because they're kind of at an angle here. So this is, the top of the cube that we're looking down on. And so the world as it stands is kind of this collection of these cubes, kind of like a voxely game, like a Minecraft-y sort of a thing, has kind of more overtly, where you've got things that are kind of made out of these like cube-like pieces, you know, sort of a situation. And I want the ability to do something like that, and I need the ability to map images onto those, right? I want to be able to put textures on there so that, you know, when we have a dungeon area or whatever, it can have dungeon imagery, you know, dungeon tile sets on the wall. If it's a house or something, it can have wood paneling, whatever, right? Basically, whatever the artists are conceiving for what, you know, you would want to put, whatever an artist might think of that they want to put on there, just being able to put stuff on there. And we need to be able to put different things on all the different sides of the cube. We also need to have some way of being able to do some lighting on here, meaning that like these kind of corners, you know, we want to be able to specify information at the corners probably that would allow us to do some sort of a darkening, you know, so we can kind of in here make it get darker when we get in areas that are like lower down and less visible, or, you know, who knows, any number of things. We may want to put lighting in there. We may want to do all sorts of stuff like that. So the problem with that is, right, that really breaks up our notion of what we are sending down to the GPU, because now not only are we sending down this notion of these sort of textured cards that are facing the viewer or doing whatever else, but we also have this concept of sort of a little bit more of a structural thing. Now, it's not a complicated structural thing. It's not the Utah teapot or whatever. It's just very simple cubes. But we're still going to need some way of communicating that information, and we're going to need some way of efficiently specifying stuff, like what image goes on each side of a cube and where the cube is, that sort of stuff. Now, the simplest way to do this would be to just specify each cube as an element, as a render element, and that may be what I do first. But we may find that to be inadequate going forwards, and we may have to adjust things to accommodate for it. But let's see here. That said, I need to blow my nose. It's getting to be allergy season here, in case anyone was wondering. All right. So, you know, if we want to do just the basic version of this, you know, we've got these sort of different render types here. So maybe I would just say, like, okay, we've got bitmaps, and I also, in addition to bitmaps, want to be able to draw cubes. Right? And a cube is just a thing which specifies the data on the coordinates of the cube that I need. So maybe I've got a render entry cube. And the cube, you know, could be specified, I guess, as just like, I mean, I guess I don't really want a cube per se because I want it to be an arbitrary height. So I need a height value for the cube. But otherwise, I just need like a radius value for the cube because it's a cube and it can't really elongate. They're supposed to be tile-shaped. So I've got a height and I've got a radius, and that specifies pretty much everything there is to specify about the cube, other than just the, you know, the point in 3 dimensions where the cube is centered about. And I think what I might do is say that's the, like, you know, oops. You know, it's like the middle of the top face of the cube. Just for now, I'm going to say that that's what that is. So, that's a cube we can specify, and I don't know if we want to specify like an x and y axis kind of a thing for it. Do we want to have cubes that spin around? I don't know. For now, I'll just say no, but because we can always add that later. And so really that's all I need, other than the fact that I'm going to need a loaded bitmap there to draw my cube, right? The texture for it, basically. And I guess I'll probably put a primo color in there as well, because that's obviously something it's going to need, just like just like the bitmaps can be colorized, so you can tint whatever you have for the color of your sprite. You can do the same thing in the case of the cube. So in order to do the cube, again, it's really not going to be particularly complicated. Inside Handmade render group, we have to do essentially the same thing that we were doing before. I know where my push bitmap call is. There it is. So inside my push bitmap call, essentially I'm doing the exact same thing. You can kind of see here we've got the version that has the bitmap loaded and the version that doesn't have the bitmap loaded yet, or at least doesn't know if it has the bitmap loaded, just using the ID. We pretty much want to have a push cube call that I guess is going to do roughly the same thing. So we've got pretty much the same parameters, I think, for the most part. I don't know that we really need an object transform here for any particular reason, because the object transform kind of just has a bunch of stuff we don't really need, right? And to be honest, we probably don't need the object transform for the bitmaps anymore either. But that's a separate issue. Anyway, so here we are on our push cube. I'm going to get rid of this for now. We've got our group, our bitmap ID, our height, our P, and I need the radius there. I'll just make these in roughly the same order they come. And then we've got that color as well. The alignment is not here. We don't have any of this. That's all gone. So we need to do the same thing we were doing before, right? And renders in background is not a thing that groups do anymore. So I'm not sure if that should even be there. I'm pretty sure that's never set for anybody under any circumstances. Yeah, I don't think it is. So let's go ahead and take that out. Is it here? There we go. So if I was to get rid of renders in background, does anyone care? Nope. And nope. Because I think that was just for ground chunks. So that stuff can go away. So in this case, renders in background, those are going away. And in this case, I've got my push cube call. I'll just weld this in at the moment here. And we'll separate them out only if we actually need to later. All right, so what I want to do here is I want to push one of these render entries. And the render entry I want is render entry cube. If I get one back successfully, I will push on the bitmap that I'm expecting. The P is going to be this P. And then I've got height, my radius, and I'm good. So my store color here still takes sort of this lerp situation. And so what I'd like to do is I'd like to kind of get rid of this as well. I feel like this color thing was only for fog, and the fog is irrelevant now because we can do the fog in the actual back end. So what we want to do is I think just get rid of this entirely and make it so that this is, you know, just directly taking what we would expect here. There we go. And doing that multiply. There we go. Let's get rid of that in this case as well. Okay. And similarly, I suppose, while we're at it, while we're cleaning things up here, we can take a look at the object transform and we can get rid of that, right? And so now really nothing should happen. I mean, all we did was add a new primitive. We just added push cube, and that's it. So, you know, we don't need anything else there for the moment. But now if we actually want to use the push cube information, we need to actually add it in here to the renderer. Now, in order to motivate that, I should probably actually make one of these things, because otherwise we're going to add it, and nobody is going to use it, and that's not very exciting. So what I'm going to do here is we're taking a bunch of these rectangles to draw these traversables. You can see that happening here, where I've got this like push rectangle thing that's happening. And you can kind of see, too, when I'm doing that, you know, I'm sort of, if I remember correctly, in world mode, we were creating our standard room. It could have variance in Z, but we turned it off. So, you know, you could have like sort of these heights and changes in various things. So if I wanted to, you know, I can get this offset Z here, I think, and I believe that'll just, you know, oh. Evidently not. Well, again, that's, you know what, though? That may just be because of setting up where the person is in the game. We do have a weird thing right now with when we actually create the player. I'm kind of interested to know in check for joining players when we call get closest traversable. We never really went in and looked at what was happening in here. Let me quickly debug that because I feel like that's a problem. See here. Because we should be able to tweak the Z by something and not have it create a problem, right? Like, I don't see why that would be an issue in any particular way, but it obviously is. And I do think that's because we've got some stuff with our way that we're doing those collision things. You can see, like, for reasons that we never bothered to debug, our hero starts over there, We do not know why he started over there, right? We were in the middle of a bunch of changes. We never looked at what was going on there. So I want to do a quick check. I have a feeling that where we're actually placing him is totally bogus at the moment. And it probably has to do with the fact that we're not placing him anywhere in particular, in any particularly smart location. So let me take a look here. Because the order in which things happen when you enter the game is a little janky. The way that we did it was just, yeah, it's not great. And it is probably something that we'll have to fix at some point. But anyway, if we come through here, you know, the way that this works is the first time through, we call check for joining players, and we do get one. It's the player who is automatically joining. And so I think we actually stuff that start value in a forced way, right? You can see here that if won this in, which we have, we basically forced the player to be pressing the button so that they would enter the game as if they had pressed it. So so we don't have to start at the title screen every time. So if we look here where we got that pressed start, that means that we are actually working with the sim region that we've set up here, and we're not actually, we don't know where the camera is yet, right? That's kind of the busted part about this, is the first time through, the camera hasn't actually been set, because the camera's not going to get set until we hit NSIM, right? NSIM is the thing that actually sets up the camera for us in terms of figuring out where the camera should go, and we're not even, you know, we're not really doing that. So I think part of the problem here is, you know, the location of the guy, you know, 000 should be right in the middle of the sim region, but it's probably not. So we'll have to see what happens there. Anyway, we look at the traversable here. Let me actually step into that. I want to see. So here's get closest traversable. I'm going to look at the closest distance squared. So the closest distance squared is 2 meters squared away, so not actually that far away, it looks like. So that's interesting, but let me go ahead and check now too. What happens if I make that change? That I wanted to make before, like so. So it finds the same location to stand, so that doesn't seem to actually be the problem, so that's good. And when we add a hero, you know, everyone's happy. And let's take a look inside the world mode camera, because I want to know where we actually are. So there's no offset to the camera in particular. And these are relatively sane values, right? We're at 7.6 in both cases. And that stays pretty, with no offset, and that stays pretty much the same, right? And let's take a look. I mean, all that looks pretty reasonable to me. Yet we get nothing on the screen. Oh, that was a little weird. We get 2 of those for some reason? No, okay. So I'm not sure why we end up with the nothing on the screenness, and I want to know why that is. I was expecting it to be something with the camera, but I'm not sure that that's actually the case. And there we do get more of an offset. All right, I'm going to take a look at what our camera is in the case where we don't do that. And I do not know why it didn't feel the need to break there, but I wanted it to. All right. So it looks like the problem is pretty simple, actually. It looks like the problem is just because we're not doing the room sizing stuff correctly, at the moment anyway. Because we're not doing that correctly, it looks like we're picking a room below where we should be picking. In fact, I suppose now with the debug camera, I should be able to verify that, though. So here's the version where we're actually using kind of scattered stuff for the cubes, right? And if I reset it to just use this one, and I should get, again, a screen with nothing. If I look up, you would think I would see, but I still don't. It's very strange. So yeah, as far as I can tell, we're definitely getting something odd where it's like we pick the room below us. You could see that the Z offset was pretty substantial in the other one. So we have to figure out what is going on there, but I'd like to pause that for a second to finish what we were doing with the cubes and then go from there. You can kind of see here how I've got all these traversables rendering as these little excuse me. Rendering as these little cube shapes, but I'm sorry, rendering as these little rectangles that are flat, but I want them to be cubes. And so what I should be able to do here is change this from a push rect, which is what I was doing before, to a push cube. And while I'm at it, I may get rid of the automatic outlining we had. There we go. So the push cube function we need to pass the parameters to it that we specified from before, and those are the group, the bitmap ID, which in this case, I guess we'll just get from the entity, I'm not 100% certain how we were doing that. I guess here we had these piece index things. And you can kind of see in here how we got this like piece count, right? And that all looks fairly reasonable. The question is, do we want to use the piece count in some way for this? If we look at the entity visible piece, it's got a color, an offset, an asset type, a height, and flags. It's probably more than we really need. So it seems like kind of overkill in this case for something like that. So I don't know that we actually want that. We probably want something a little more straightforward where we're just specifying more of an image here. But I don't know. So we could just say that, you know, if it's got a traversable like this, I guess I'm just going to say, you know what? Maybe we just get rid of this, and we say sure. We go into the piece index stuff. That, you know, can do what it's going to do. We have the bitmap ID situation, and we can then say, all right, instead of a push bitmap call, it doesn't have to be a push bitmap call. If we want to, it can be piece type, you know, cube. And if it is a cube, then we'll just use some of this information to derive how big the cube should be. In this particular case, we sort of have a situation where I guess we're over-specified. You know, we have this notion of the offset, and maybe we can just use the offset as the 3 values that we want. And I guess we could make it so that the cube actually takes each individual dimension separately as well, since if we are always passing that down. And we don't really need the height in this case for anything in particular. So I think we can just do something more like, well, I guess we do need the offset there now that I think about it, because we do actually need to say how it's offset from the entity potentially. So that's not actually true. So we do want that in there. So we're going to have to figure out another way to pass that information. So we've got the height, and I guess we need kind of a radius value here that we don't have, right? And of course, color we do have. So that's a good question, and I'm not sure exactly where I want to get that information from. It seems like that's something that just wants to be in there separately, because you can see here when you're passing that height down with push bitmap, you know, that's the kind of thing that you probably in the future want to be able to control separately both of them. So I feel like that's just something that in general we would want. So I feel like we want something maybe more like that, where that's actually specified as a dimension. And in this case, we could do, you know, height equals dim 1 or whatever, or dim.y. So when we do a push bitmap, we'll use that, and when we use it in this case, we'd pass it like that. So then when we're doing add piece and we specify a height like this, that would, you know, translate into something like this. I don't know exactly what we want that to be, but something like this. And then if we're adding a cube, we would add it slightly differently, right? And we could have, you know, this parameter could just be passed through, I suppose. And then when people call add piece, in this case, you know, they would pass the v2. Of course, there's so many people that call that. I feel like we want to keep it the way it is. So I feel like I want one of these that does do that translation for you. And that's literally just a thunk. It does nothing but wrap it for you. So I think that's reasonable. And that way we can have cubes that are kind of mixed in here with everything else as part of an entity anytime we want. And that seems good. The cube, render cube call, I do feel like maybe taking the height as the second thing makes a little more sense there. So we'll maybe leave it like that. But otherwise, I think we're good. So we run this now, and you know, we took out those push vector calls, so those are gone. But now, you know, we can verify at least that everything else is working just fine. And all we need to do now is actually put in some, for the things that have traversables, like those ground points, we just need to give them individual pieces that they can actually work with. So if I go to the world mode where we create this, inside add standard room, we've got these places where we're making these entities right with floor collision. And in here, they never have any actual pieces to them. So all we really need to do to finish that off is we just need to actually add a piece. And if we take a look at how we call this, we just need the entity we're trying to add the piece to. We need the asset type. Which in this case, there we go. In this case, I'm not sure what we're actually adding here, but you know, I guess maybe rock or stone. We need to actually put in some real art soon, because none of this stuff is going to make any sense unless we do. But you know, all right. So maybe there's maybe there's grass. There we go. So the asset type in this case, we'll just put something in there random for the moment. We need the height and the radius here. And in this case, since we have in the entity, we kind of know what we were doing with that before, just because we happen to have it here. It was 1 for the radius for whatever reason. For the height, I don't know what we want. Probably like, you know, 3. We want these to be fairly tall. Maybe not. Maybe just 1 meter is fine. Who knows? And then we need the offset, the color, and the flags. So the offset in this case is actually, it's a little tricky because I know I said before, I was like, well, we'll just make it the top of the cube. But now that I think about it, it's like if we're going to allow this to be sort of a general thing where entities can just have cube pieces to them if they want, that makes it probably a little more compelling for us to make it be the center of the cube, probably. I don't actually know that that's true. It may actually still make more sense for it to be pivoted at the top because, you know, if you imagine it was sort of like an appendage or stuck to something, that make more sense. So I'm not sure. That's a really tough question as to how it should be constructed, as to whether it should be centered or not. And so I guess I'll leave it with top for now, and maybe we'll live to regret that quite a bit. It's really hard to say. So let's find out. The offset in this case will just be v3000. The color can just be white for now. Don't have to really do anything with that. And the flags can be like piece type cube. And off you go. So the piece type cube situation is now in theory in full effect. It should get actually executed upon. And so my assumption is now we will get an assertion in the renderer, hopefully, yes, which tells us that now we're actually getting cubes seen down in the renderer. So we just need to have the cube primitive be something that actually is understood by the OpenGL renderer, which in this case we can do. We're not going to do anything fancy. We're just going to do very, very basic. And we'll base it here on, here we go, on our render entry bitmap. So OK, we've got our render entry cube here. And that's really it. And, oops. We then need to actually output this cube. We're going to go ahead and bind the texture. And then we need to do essentially the same thing as we were doing up there, but with a little more, I guess I should say a little less fussing, because we don't have to do as much work in this particular case. So what we want to do now is output the triangles of the cube. We could do this with a little more finesse. Than we're about to, but we need to start somewhere. So here's Mr. Cube. And we just need to generate some points and triangles that will define this cube so OpenGL can draw it, right? And we know we've got 8 vertices in a cube, right? 8 corners of the cube. And we know that every side of the cube is a face. There are 6 faces, and each face has 2 triangles in it, right? Because each square has 2 triangles. So if we want to, we can imagine creating this pretty straightforwardly, right? We just need to talk about these points in terms of the axes that we're thinking of here. And so, you know, you can imagine here's my y, here's my x, here's my z. Same as we normally draw. And we've got each of these. These are sort of the positive z ones. These are the negative z ones, right? The positive y ones would be up here, negative y ones down here, positive x over here, negative x over here, right? So we can kind of think about those, all of those things, all of these corners, essentially in that way, right? This corner right here is negative x, right? Positive y, negative z. I'm sorry, positive z, right? So, in fact, if I just labeled them, negative x, positive y, negative z, this is negative x, negative y, negative z. Sorry, positive z. I don't know why I keep lining like that, positive z. This is positive x, negative y, positive z. This is positive x, negative y, negative z. This is positive x, positive y, negative z. This is negative x, positive y, negative z. This is negative x, negative y, negative z. And now we've got all of the different points. So if we want to create each of these individual faces, oops, forgot one here. This is positive x, positive y, negative z. Positive z, rather. So if I have all these points, now I can just think about actually just putting in what the cubes should be just manually. It's pretty easy, right? You could imagine saying, all right, I've got a bunch of points, let's say, here in 3 dimensions. And maybe I use like lowercase for negative and uppercase for positive. So, you know, I'd have x, y, z, x, y, z, x, y, z, right? And in fact, I guess I could do this a little more systematically. Maybe vary z each time. It's a little hard to see. I don't know how good of an idea that actually is. I wish the z's were a little bit more clear in this font, but they're not. So you can see here, I've got the z lowercase, so I've got negative z, positive z, and then the y goes positive, negative z, positive z. Now let's go make the x positive, same thing. And there's all my 8 cases, right? Since that's a little hard to see, I don't know, I think that's maybe not such a good idea, so here's another way I could do it. I could do like, you know, px, py, pz, and like nx, ny, nz, or something like that, right? Is a little easier to see. So if I'm going to do it that way, I've got negative z, positive z. And then I've got the positive y versions of those two. And then we just make the positive x versions of all of those. So that seems reasonable enough, I suppose, right? And so all these are going to be is they're just bundles of the values, and I could literally bundle these values exactly as they are written, right? So it can just be this sort of thing. I suppose now that I think about it, if I want to, I could just use the OpenGL immediates for this even. In fact, why not do that? So I can just specify the negative z, the positive x, sorry, the negative x, the positive x, the negative y, the positive y, the negative z, the positive z. And then in here, I can just do this sort of thing. All right. So what we will see a lot is if I want to do this, and I'm specifying a GL triangle, in order to specify the face of a cube, I'm going to have to do something like this. If I've got point 0, 1, 2, 3, and I want to draw a quad, what I have to do is I have to specify one triangle that is 0, 1, 2, right? This triangle right here. And then I will have to spend another 3 vertices to specify another triangle, 0, 2, 3. Rather than type that out, I will just make a utility function for that. If I don't have one already, I don't think I do. Yeah, so you can see here we have OpenGL rectangle, which is basically the function that we want. The problem is that the function itself has this kind of nasty habit of specifying the begin as part of it, which we don't really want. But this is mostly what we want, so I can make another one, which is just like GL quad. And in this case, I can go ahead and I can go ahead and be a little more specific here about what we're specifying in terms of the points as well, because you can see here that it was not actually giving me the freedom to specify these points because it's assuming the min px, min py, that sort of thing. So I guess in a sense, this wasn't really exactly what I wanted, but what are you going to do? All right. So I'm going to have a GL quad call here. I'm going to be able to pass it a PML color. I think what I actually want to do probably is say, I've got P0, which is, the point down at the bottom there. I've got the texture coordinates for it, and I've got the color for it, let's say. So I can pass all three of those in, and I just pass 4 of those. So it's all of the actual information that I need. Will just be over explicit there, and we can always simplify it later. So in this case now, I know what I want to do is I want to specify like GL color for FV, and I'm going to pass that color 0, and I'm going to specify the texture coordinate, and I'm going to specify the point as well. So that's an example of how to specify one point. We specify the color, the texture coordinates, and the vertex data. And like I said, I want to do 0, 1, 2, and 0, 2, 3. So there's 0, 1, 2. And 0, 2, 3. And you'll notice that when I did this, I was careful to always keep these wound the same direction. So you can look and see I said 0, 1, 2. That's wound counterclockwise relative to the facing direction. And the same is true here, 0, 2, 3, again wound counterclockwise. And the reason that I wound them both in the same direction that way and also both counterclockwise is just because if we ever want to use backface culling, right? Backface culling is a concept that just indicates that, hey, if I'm looking at a closed object, right? Like let's say I'm looking at this this cube that we're talking about, the one we're actually building. Well, it's closed. There's no holes in it. There isn't like a hole in the top I can use to see into the inside. And what that means is that you can only ever see the front of the faces of the cube, right? You'll never see the backs of the faces of the cubes because if you turn the cube around, you'll just see the other side of the cube. You won't see the other side of one of these faces. You'll see the other face of the cube that's on the corresponding opposite side. So given that, what it means is that the hardware, the graphics hardware, can actually early out anytime it does a transform and finds that the points for a given face are wound in the incorrect order relative to the screen, because what it knows is that if you always specify them wound a particular way, if I always specify 0, 1, 2, and they're always wound in that counterclockwise fashion, then what it knows is if this cube were to spin around such that now this face you know, here's my cube again, such that now this face is actually in the back here, right? It's one of the back faces of the cube. So it can't actually be visible because we know we can never see that. It's a closed object we'd never see in there. It's not possible. We know we can eliminate that face right away because look what happens. This 0 point is now here, right? This 1 point is now over here. And this 2 point is up here. And what you'll notice is 0, 1, 2, it's now wound the other way, right? And that's exactly what happens as you spin something around, as it flips, as it goes from being front-facing to you, as facing you, to being back-facing to you, it flips its orientation. And so I was careful to wind them that way so that if we want to turn something like that on, we can. And so, you know, that was sort of a little something that was implicit in what I did, but that is why I did that. It wasn't arbitrary, it was intentional, just so that's clear. So if we take a look at the cube situation here and now, and I come through and put in this GL quad situation here. So what I can probably say is if I used this thing, and now I'm back to what I was thinking about before too, where I actually do need to pack them in. But anyway, so if I go through my GL quad here, what I'm going to need to do is I'm going to need to specify all the faces of this cube here, right? Every last one of them. And so, you know, I'm going to want to specify them in this way. So here's one face like that. Let's see what it is. It's going to be a positive x, right? Positive x, negative y, positive z. And the next one's going to be positive x, negative y, negative z. The next one's going to be positive x, positive y, negative z. And the last one's going to be all positive. Positive x, positive y, positive z. And then the same thing is true for all of these. I guess it's also, now that I think about it, I wonder if I just want to do it a little simpler and just say, okay, if I just do 0, 1, 2, 3. So if I did it in Z, it might be a little clearer. So let's say 0, 1, 2, 3, 4, 5, 6, 7. Something like that. So let's try that again, because again, I think that's just going to be a little simpler for us. So if we do this GL quad here, and I want to do, let's say, this front face right here, that's just 0, 1, 2, 3, then this is the entire code for that. If I wanted to do the back face, it'd be 4, 5, 6, 7, right? But again, I want it to be facing the correct direction. So rather than 4, 5, 6, 7, it would actually go the other way round, right? It'd be 4, 7, 6, 5, or 7, 6, 5, 4, right? Because it needs to be wound counterclockwise relative to somebody looking from the back, if that makes sense. So 7, 6, 5, 4 is really what that should look like. And we do have a little bit of a concern here too with the texture coordinates. These are not really going to be correct because we're going to want probably different texture coordinates in a lot of cases for these. So that's a little bit harder to envision. In fact, for the time being, I might actually leave these as just always this way. And we'll play with those later, I think. So I'm just going to focus on just the positions instead. So now I've got this face, right? I've got this front face and this back face. And now I need to do these ones around the side. Let's do the ones, the bottom and top faces next. So the bottom face is just 0, 1, 5, 4, right? But again, that would be if it was facing us. It's not, it's facing away. So I need to do it the opposite direction, right? So that's going to be 4, 5, 1, 0, right? It's going to be wound this way so that when we're looking at it from here, it'll be counterclockwise, right? So we want it clockwise to us, basically, 4, 5, 1, 0. We then want the top face to be wound the way we would expect. So 2, 6, 7, 3, right, would be the correct winding for that. And in addition to 2, 6, 7, 3 and those two, we need these final two faces here, which are these guys. So that's the one we originally started with, 1, 5, 6, 2. And then finally the back one, again, it would be 0, 4, 7, 3, but we're not going in that order because it's facing the other direction. So it's actually going to be 7, 4, 0, 3. And that's actually all of the faces of the cube. So what we need to do now, and I guess I probably want to leave those in place there, is I want to create these actual things. So I'm going to, for the time being, actually just have the color be the color. Although, you know what? To make it easier for us to see, too, maybe I'll just do this. So that way we'll be able to see the corners of the cubes very nicely before we start playing around with any other information about them. For these, I'll just set them to something pretty basic, and we'll leave it at that. The other thing we can do here, if we want to, is we could turn off texturing just for these so we could see them a little bit better. I don't know if we have any particular... I don't know if we have anything particularly useful for textures that we would really apply here. So what I might do is just say, let's just turn that off temporarily so we can see our cube, and we'll deal with the rest of it later. All right. So we have some more work to do here. Obviously, we have a bunch of other work to do here. I guess these just want me to hand hold it so it knows how to find the float in there, and that's fine. There you go. And so if we take a look at this here, we've got these cube points, and we just need to generate what they actually are. So in order to generate the cube points, I'm just going to go with what we corresponded in the diagram. And so you can see 0 is negative, negative, positive, for whatever reason. That's what we did. Not sure why. Positive, negative, positive is 1. 2 is all positive. And 3 is negative, positive, positive. We then did the exact same thing on the back. So 4 is negative, negative, negative. And then we did positive, negative, negative, and positive, positive, negative. There we go. So those are our points. And all we really need to know now is what those sort of positions actually were. And so if we take a look at how our cube is specified, right, we have our cube P, and obviously the x's will start with that, which is the centroid, and then they're just going to subtract or add the radius. Oops. And the same would be true of the y. So again, just subtracting it or adding the radius. Finally, the z is a little bit different. In this case, instead of subtracting and adding anything, we were saying we were going to have the top, which is the most positive part, be at 0, and then we're going to have the height. So to get the negative, the minimum value, we have to do a subtraction now. But those are all of them. So now in theory, we were actually drawing cubes, I mean, assuming that we didn't screw something up. And they're not going to be pretty, right? They're going to be real ugly. And you can see that they're actually really ugly there. There's our cube. And everything looks good about this except for the fact that they're all in the same place. So we must not be setting the offset of our cube properly. So I got to go double check that. But otherwise, you can see our cube is kind of what we wanted it to be, and so that's good. You know, yay for our cube. That's all fine and dandy. So let's go ahead and take a look. I think that we just, when we were specifying the pieces here, right, we specified the offset as 0, 0, 0. I think we never actually in entity offset that by the traversable position or whatever it was that we were trying to do there. I don't think we actually managed to do. So in push cubes, yeah, we just passed the piece offset, and we didn't use the entity transform at all. So the entity transform in this case, we want that offset to be baked in there, right? So now we've got all our cubes. I don't know, since we're subtracting out of the radius, I guess the rectangle was a straight dimension. So the fact that we're using this as a radius now, we would have to have the value. So our cubes are too big. But otherwise, our cubes are correct, it looks like, for the most part. That looks pretty much right to me. And those look like they're drawing in the right place. And so all of our cubes are kind of happy, and that's all good. But obviously, we still have the problem that I was talking about before, which I need. Well, we've got a couple different problems. One is now we have to deal with how our stuff intersects or doesn't intersect, as the case may be. So we're going to have to take a look at that. But like you can see, for example, this tree here and this cube and how they interrelate, that's going to be kind of a problem for us. And we're going to have to, you know, have a sane solution for how we're dealing with that stuff. Like probably what we want in most cases is we want sprites for things like trees to, you know, always be in front if they started in front, you know, and we don't really want to deal with the interpenetration, right? But you can see with how these things are lying, and again, you can see why I wanted the debug camera stuff. You can see with how flat those are lying, we just have this problem with how they're going to interpenetrate with each other is going to cause problems for us, and so that's just something that we're going to have to deal with. All right, so let's just take care of some housekeeping here. We have some time left in the stream, although I don't know how much. We started at 10:30, right? So we'll be done at 12:30, I think. So we have about 15 minutes left. So we got some more stuff we probably want to do. OK. So taking a look at this, for example, first of all, we could try to find that bug, because we know we have a bug with the way that the world rooms are working. That might be a little bit too much to start dealing with now. So for the moment, I'm going to ignore that guy, and we will tackle him probably tomorrow, I think. Would be the best time to take a look at that. What I'm going to do instead here is just say, OK, what I can do is I can reduce the variance of some of these to produce a more reasonable set of ground positions, like so. which is a little more indicative of probably what we would be doing in the game anyway. Here is, you know, the hero. I'll have the hero kind of come down the screen here. Oh, that was very strange. I think this monitor is getting confused because I don't think I'm varying anything. Well, maybe I am. That's very strange. All right, anyway. So this is more or less what I wanted. You can tell, though, it's going to get pretty rough in here if this is actually how we were drawing all of our cubes in this weird psychedelic crazy way. So we probably don't want to be doing that at the moment, even just for debug purposes. So now that I know that our cubes are correct, I'm going to go ahead and switch to drawing these cubes in slightly more sensible in terms of their colors. Something that we can actually use. So if I come in here and set the colors to something that actually is representative, so here's the cube color itself. And if we set the thing to the cube color, sorry, pre-mul color, we should be able to get sort of something that's going to be a little more stable for us here. So first off, if we set a texture on it, like I said, I don't know that we have any textures. I'll try to find one here that I can use as a starting point. But I don't know it's going to work particularly well. Let's go ahead and start that off. So you can see, like, that's now each face of the cube has one of those little dudes, one of those little grasses on it. Unfortunately, all of those were made when I thought, you know, those were just some test textures that we threw in there that were made when I thought we were going to do stamping. And I don't really want to do stamp anymore because the point was to make things much more cube-like. And so we kind of need some way of making those, we need something that's going to be more usable there. I don't know that we have anything at the moment. We should probably update to the new art pack. I guess that's something that we probably should do soon, just so we have the right stuff to play with here. I'll have to go talk to Anna about that and get the latest stuff from her so we can do that. But is there anywhere to go here? Can I go out of here? But otherwise, that should be okay. The thing about it is, again, we probably want some way to do some lighting there, which we don't have at the moment. We really don't have any way of distinguishing those. So we also sort of have this problem of wanting to be able to specify some of those cube colors a little more independently so that we can have them sort of reflect their, you know, where they are roughly and how they should be colored differently. So there is a little bit of that. So I'll have to think about how we want to deal with that. Oh, and here you can see this is the case I was talking about. So good. Let's go ahead and get in there. So this was the case I was talking about that I wanted to have sort of an answer for. You can see here there's this cube. And it's a little obviously difficult because I wonder if there's any, what if we have anything at all that's an asset we could use in that location that would be more, we just want a flat, like, grass texture that doesn't have soft edges. I just don't know if we had one in that pack. I don't think we did. Yeah, I really just don't think we did. I'll try a couple things here to see if there's anything. I could try some things and see, but I don't think there is. Oh god. Yeah. I think we are SOL, my friends. So yeah, I guess I couldn't say. I guess I'm going to leave that till we have something better for it. But all I was trying to point out is you can see here that you've got a cube, and the tree is sticking directly into the cube, right? And so when you view it from above, you're going to get that artifact. Now, that artifact is not necessarily an incorrect artifact in certain senses, meaning, you know, we're, again, because we are still a 2D game, I'm just using some 3D rendering to give us some nice effects and some better performance than what we would have if we had to do sprite sorting and stuff like that I wasn't happy with. So it's not necessarily that that's wrong. It's just that, you know, when we're creating this world that doesn't quite exist right because we've drawn 2D assets but we're using them in a 3D way to produce a 3D sort of effect, you do have to sort of figure out how you're going to account for the fact that sometimes you will end up with 3D problems with that 2D fakery, and you need a way around them. And so that's what I was talking about in the situation where, because these things actually are leaning like this, when you look at them from the side, they can interpenetrate with relatively low stacked things behind them, and that's bad, right? So what we need to do there is we need to have some sort of a way to combat that, and that's why I think one of the things that we probably want to do is have that sort of fake Z, so that things that are upright cards get fake Z buffer values to allow them to sort differently than they would otherwise. And I don't know, again, like I said, if that's a good or bad idea, but it seems like the right idea for the time being. We're about out of time, so I will go ahead and go to the Q&A for now, but that's roughly what I wanted there, so I think we're good. We need to do, oh, well, you know what? In the 5 minutes, what I can do too, though, I can also go into our sprite code and re-enable the shearing, because that's really easy for us to do now. So, you know, right now you can see our hero is not shearing or doing any of those sorts of things that it used to be able to do. The reason for that is because inside the render group, when we're pushing down these axes, we're just using the camera X and camera Y directly, and we're not ever using the X-axis, Y-axis that we're actually getting past here. But what we can do pretty easily there is we can modify the code that we were placing here. So we get our X-axis, Y-axis. We can actually produce those axes by reinterpreting them along the camera's X and Y axes itself, right? So we know, for example, the X-axis is X is talking about something that goes along the camera X-axis, and we know that the X-axis Y is now something that goes along the camera's Y-axis. So we can actually reproduce what those axes, those rotated axes or sheared axes, depending on what we got past, we can just reproduce what they would have been in the camera plane by using the camera's two basis vectors for that purpose. And then you can see that we re-enable the shearing that we wanted exactly like it used to be in 2D. It's now in 3D in that plane of the camera, right? And that's exactly what we wanted. So again, getting closer to a regular 3D version of the world here, and you know, when we go ahead and fix alpha and get some real bitmaps in there, we're getting very close to a proper, you know, a proper thing that you could actually show someone and say, here is, you know, a reasonable looking screen. But we do have quite a few little things to take care of before we get there, right? All right. So let me go ahead and go to the Q&A. Masilda asked, any particular reason for using counterclockwise for front faces as opposed to clockwise? No, not really. So the choice is arbitrary, and in fact, not only is the choice arbitrary, but you can also pick this. So 3D APIs and graphics cards let you determine which faces are culled and which faces are drawn, whether you want counterclockwise faces drawn or clockwise faces drawn. So the choice is purely arbitrary and up to the programmer in all practical senses. As to why it is typically used as counterclockwise in modern circles, the reason is math. And so I talked about the concept of a right-handed coordinate system. And a right-handed coordinate system, again, is one where if I was to draw the coordinate system and I was to take my hand and put my fingers so that they curl from X to Y, right? And I look at what direction my thumb sticks out. That's my thumb, apparently. My thumb sticks out along the Z-axis. Right? So if you take a look at just that, right-handed curl, it's a right hand. If you take your right hand, you curl it from X to Y, and your thumb points out along Z. That's the concept of a right-handed coordinate system. For whatever reason, the majority of math favors right-handed coordinate systems. It favors coordinate systems where Y is up and X is to the side, and Z comes out at you, right? Comes out of the page of the math book, if you will. And that is the right-handed coordinate system. The cross product and geometric algebra is typically written in right-hand terms. So when you're talking about things like sheets and you have vectors that point out of the sheets, that's usually right-handed in that the winding of these sheets is that way and the thing goes out that way. So the reason that we tend to order vertices counterclockwise is just because if you tend to be favoring right-handed as your standard for how you're doing math, you think of a face as if you were to curl your fingers in counterclockwise, your thumb points out in the direction the face is facing. And so again, that's another just example of right-handedness there. And just to be clear, this has nothing to do with actually being left-handed or right-handed, because it doesn't matter what your dominant hand is, obviously. You can curl either one. So a left-handed or a right-handed person, no one is at a... It wasn't like the mathematicians got together and decided they liked right-handed people better than left-handed people or something. For whatever reason, that's just the orientation of the coding system. It has nothing to do with whether you're right-handed or left-handed. It's just saying which hand tells you the winding and the axis direction. That's about it. And in some sense, you would think if you know, suppose there's significantly more right-handed people in the world than left-handed people, but oddly enough, if you think about it, mathematically speaking, this is actually made more for left-handed people than for right-handed people, because if you are doing math, you probably have a pencil in your dominant hand, and your dominant hand, in the case of a right-handed person, is their right hand, which means they cannot actually curl that hand to check. So it's actually a left-handed person holding a pen or a pencil doing math who can actually invoke the right-hand rule fastest, not a right-handed person. So I don't know why they picked it. It clearly wasn't to favor right-handed people. If anything, it sort of favors left-handed people. I don't know if there was a deeper reason why counterclockwise is important. It could be in that math way that like there's some weird nonsense about like quantum physics is right-handed by nature or something weird like this, where the windings are that way. I have no idea. You know, sometimes stuff like that comes up and you're like, oh no, it's not arbitrary. It's here for a reason. That could be. I have never heard of one though. Like no one's ever told me, oh yeah, it's because of this fundamental physical principle. So it makes sense that math should always be, you know, this way. So I don't know why it's that way. That's just what it is. This Isaac, a debug camera pan control might be a good idea. I do agree. That's probably true. Probably wait till we actually need it, but yes. Core activities. Why have everything slightly tilted? Wouldn't it make more sense to sort the assets according to their bottom, or if you're using 3D space, go for an orthogonal camera and using the Z position for sorting? So I think there's kind of two questions in there, because why have everything slightly tilted is an aesthetic question, right? Not a programming question. Whereas the second part was a programming question. So I'm not sure if those are supposed to be related. They don't sound like it, so I'll answer them separately. But if they're supposed to be related, you can let me know. So the reason I kind of like having everything slightly tilted, potentially, is it just adds a little bit more visual interest, right? It adds a little bit more depth to the scene. So you know, if I've got the debug camera here, I can play certainly with various ways of keeping this scene oriented. And if I want to, you know, I can have it be straight up and down. The problem with having it be straight up and down is I would lose a little bit, potentially, of that sort of ability to harmonize the sprites with the background, right? And what I mean by that, and you'll kind of see, you can actually see this in the way that we are doing the Handmade hero art, which we should probably, like I said, we need to put it in sometime soon. Let's go ahead and go to Molly Rocket. So if you take a look at the way that we're doing the Handmade hero art here, you can actually see that we're taking a pretty top-down perspective to it to try and keep it closer to the actual perspective of the action. And so part of making those sprites be part of harmonizing them with the background is perhaps reflecting that tilt a little bit in the perspective of the background so that your eye has to do less work to sort of harmonize those and understand things spatially, right? We could have made it so that you were directly top down, but then you lose a lot of the character of the sprites, because if you're directly top down, you can't really even see someone's face. And so there are games, you know, like Hotline Miami, for example, or something like that, where you take a look at the way they did it, and it is directly top down, right? And so that's not necessarily, I guess I can actually get a bigger, there we go. So that's not necessarily a bad idea, because you can see games that have done it and you know they work, but it definitely has the effect of distancing you a certain amount from the character of the game. And in some cases, like Hotline Miami, that may be very appropriate. I mean, this is a game about kind of a lot of you know, mass slaughter and some, you know, crazy action sequences where everyone is dying, including you, all the time, and there's blood everywhere, and it's you know, a giant sort of essentially desensitized thing. It makes some sense to go, you know, we don't really necessarily want this game to be about seeing the characters' expressions or anything, because that, you know, there's a lot of reasons why you wouldn't want that. But in a game like Handmade Hero, it's a little bit different, where we kind of have these characters that you did want to see their faces, so it's a little bit more angled like that. And so that's why I think I might like it to be, it might not be this angled, but it might be a little bit angled in terms of the way in which the camera is placed relative, in terms of tilt, relative to the world. That's just my gut feeling. And again, these are not, that's not some kind of a prescription or saying you have to do it that way, because every game is different and the appropriate thing to do in any particular game is definitely different. So, something like this is probably what I would be looking for, but again, I'm not quite sure yet exactly what I want there. But that's the basic idea. As for your other questions, which was sort of more about programming, not the aesthetics of it, you said, wouldn't it make more sense to sort the assets according to their bottom? And the answer there is that you actually can't do that. So we spent some time on Handmade Hero looking at that, and that does not actually work for any kind of complex sort of scene that you might want to create. There's a bunch of cases that don't work if you sort that way, and there are a lot of cases that we wanted. You can go back and watch the episodes on sorting where we talk about this in a little more detail. I would also recommend you, let me see here. It's Retro City Rampage. I would refer you to, not that one. Is it Retro City? What's the new? There's a new one. I can't remember the name of the new one. It's not Retro City Rampage. It's Retro City something else. River City Ransom, that's what it is. Sorry, I got that wrong. So I would highly recommend reading this because it's laid out in a nice, concise blog format. And basically, this is a case where Andrew Russell took some stuff we were talking about on Handmade Hero, and he was like, oh, hey, I've already had to deal with this in the game that I was working on, which is River City Ransom. And let me tell you more about how I did it and sort of like what we're going to do here, right? And so he points out some really obvious, when you think about them, but not obvious until you've actually gone through the work, cases where you need to do relatively complex things if you want sprite worlds to sort properly. And they all have to do with the fact that perspective is kind of baked into sprites when artists draw them. And you can kind of see here this really simple example that you wouldn't think twice about, where, for example, you've got this car here, and that's all you really needed to know, right? Is there's a car, and I've got some sprites. Well, just sort them by the baseline, like you said. But of course, it doesn't work at all to do that, because you may find that depending on where they are logically relative to these things, it may be that sometimes sorting by the baseline works, and sometimes sorting by the baseline does not work, right? And so what he found is that the only real way to do that particularly well is to actually use some logic about, he actually has some voxel information in there, use logic about how the perspective is encoded in the sprite, and use that, which is pretty hardcore, right? So hopefully that blog entry, I don't know the easiest way to get to it, but let's see what the minimum search terms are. So river sprite sorting seems to be the quickest way to get there, maybe. I don't know if that'll actually work or not, but I would highly recommend that blog entry as a good way to just kind of be like, oh, okay, I see why this is a little bit harder if you actually want to have some complex cases. Obviously, you can design your whole game around avoiding these and then sort by the baseline. Certainly, you can special case stuff and sort of hack together something that works. But I was kind of more interested in something that would be a little bit more expressive and not require a lot of special casing. And so this is what I felt like was the most logical thing. In terms of your final question, which was, wouldn't it make more sense? I'm sorry, if you're using 3D space, go for an orthogonal camera using the Z position for sorting. And the answer is, I'm not sure I really want an orthogonal camera. I like, we've done some stuff with like rooms stacked on top of each other, and I kind of like having the perspective in there. So I don't know that I really want an orthographic camera. So we're probably going to stick with the perspective camera, even if we only use relatively subtle camera effects. That's probably still going to stay that way. And it's not particularly hard for us to deal with, really, I don't think. Because like I said, the only real artifact that I'm thinking of is the one where we just is the one where things are very sort of, because they're very slanted, they interpenetrate things behind them. And all I really have to do is modify the Z value for the depth buffer, and I think I'd probably be okay there. I don't think it's going to be too bad. Masielda, I noticed the camera in Handmade Hero is defined by camera X, Y, Z, and P. Can I get X, Y, and Z from a quaternion? Is that a good idea? I mean, if you had quaternions on Handmade Hero, would you define the camera using a quaternion and P? The answer is yes. If I had quaternions in Handmade Hero right now, I would use a quaternion and P, and I would generate the X, Y, Z axes from the quaternion. It's not particularly difficult because a quaternion, one of the first things that you will learn to do if you learn quaternions is how to turn a quaternion into a matrix. And if you turn a quaternion into a matrix, as I've sort of gone over multiple times in Handmade Hero, you know how to extract the axes from that. So you can just look at the math for turning a quaternion into a matrix, and it's very clear just from looking at what the terms are of that matrix, exactly what the terms would be for the axes. So it's very, very simple to turn a quaternion into a set of 3 axes if that's what you would prefer. And so in cases like these, when we want to be able to access those, there's no mystery to it. It's really no different. It's very straightforward. All right, let's see, last question. What is the X in B32X and U32X? Those are there just to specify that I don't actually care if they're 32 bits, just that they are as long as 32 bits, or rather can store 32 bits, but they could be 64 bits or anything else. I go back and forth on some of these things. One of the big problems that you end up with, so there's a lot of issues, right? And I don't want to go down a huge rat hole on this because it literally has nothing to do with, anything that we're going to have to really think about at all here. So it's not critical to Handmade Hero, but I'll just point it out. And that is that there's usually 2 things that you need to specify in when you're talking about a variable or a member of a structure or whatever. There's like exactly, n bits and at least. So when you think about these cases, why do you need them? The answer is that if I'm doing something like structured use of memory or reading from a file, then exactly n bits may be important. The reason it may be important is, let's say I've got something like a bitmap header on disk, and the specification for the bitmap header is like it's got a U16, right? So it's got an unsigned 16-bit value. That's like, you know, the width or something, and a U16 that's the height. And this is in my header. Well, I can't very well tell the compiler, you know, there's a width value and it's got to be at least 16 bits, but I don't really care how big it is. And then another one that's a height value, because I'm reading these out of the file. And so if I expect to read them in a block and then look at them right in the file, in memory as they were in the file, it has to be exactly 16 bits, because the next value starts right there. After 16 bits worth of information comes the height. So I need to be able to say, for laying out things in case they're in file formats or in case they're getting transmitted over a network, where they're going into a data format that has to be understood by multiple machines that maybe have code working on different compilers or different languages, this has to be specified exactly. And so one thing you're doing is specifying exactly n bits. And so in my parlance, I use like U16, U32, S16, whatever. I use these for exactly. But there's other times where you don't actually need things to be exactly. And in that case, I try to use a syntax. I didn't really do it on Handmade here originally, and then I started doing it because it was just such a force of habit. So I apologize. It's in there now. But my intention was to skip it, because I didn't really want to get into it, but I ended up doing it anyway. And at least n bits is like U32x, U16x, etc. These are saying, well, I need 32 bits of space because the algorithm requires that much. But if your operations are faster on 64 bits instead, use it. Because some CPUs are faster when they don't have to downshift to smaller than their native size. Sometimes it's more expensive. It takes more operations, for example, you know, on something, I don't know, probably like I think a PowerPC had this at one point. Certainly Intel had it, I think, at one point with U16s. I can't quite remember, though, where there were cases where using the 32-bit values is faster than using a 16-bit value, so forcing the compiler to use a 16-bit value can slow it down, right? Again, not always the case. On modern Intel CPUs, like the ones in this computer right here, I don't know that there's any penalties of that nature. Off the top of my head, I can't think of any penalties for using a smaller type than a larger type at the moment. That doesn't mean there aren't, I just can't think of them. But that is not always the case, and on different platforms you will encounter this problem, and so I try to notate my code, at least to a certain extent, with that information, so it makes it easier for me to tune it later on platforms like that. How much time and effort do you spend preparing for each episode? 0. One of the requirements I had for doing this series is I wanted to basically have to do everything on the stream with no preparation. So there's never any preparation. I just sit down and do the series programming what I would, you know, as close as possible, doing what I would normally do in whatever the programming situation is. And I just try to explain it as I go. Oh, and Masfielda asked, why B32X and not B1X or B8X? That's another good question. So, you know, I use B to indicate a Boolean, right? And so the question is, why not B1X? Because a Boolean only needs 1 bit. Surely you don't need 32 bits for a Boolean, so isn't 32X, kind of wrong? The answer is because that's not actually what I use that syntax for. When I use B, B is just letting me know that I intend the value to be used in a Boolean fashion. So 0 is false and any other value is true. That's all the B means for me. So what the actual size part means is what I expect it to harmonize with, because I'm going to be using those values intermixed with other integer values. So the answer is I pick the Boolean size based on whatever the size is of the stuff around it that I'm using it with, typically. But that's it, if that makes sense. And dude in basement who is asking, can we do cubic spline sometimes? We probably will do a cubic spline on here at some point, but I would just point out the fact that that's actually up here somewhere. Yeah, here it is. So if you go to this stream, this is an hour-long stream that explains cubic spline interpolation really explicitly, right? You can kind of, it has everything from start to finish on cubic splines. So, if you want to check that out, that's everything that we would cover on this. If we get there, it's already in that video. All right, so that's about it. I'm going to go ahead and close it down. All right, everyone. Thank you very much for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along the series, you can always pre-order the game on handmadehero.org. It comes with the source code, so you can play around with it and experiment. We also have a forum site you can go to if you want to ask questions. We have a Patreon page you can use to support the video series. We have a schedule bot, which tweets the schedule at you if you want to know what days and what times we're going to be live. And then we have an episode guide you can go to if you want to catch up on old episodes. That's about it for this week. I'll be back. I'm sorry, not for this week. For today, I'll be back tomorrow. When we can, I think we just need to do some debugging now. There's a couple bugs in there that we need to take care of, and I don't know. Maybe go ahead and do the split sorting for things like shadows that are going to have to be drawn in a second pass. So we can probably do those two things tomorrow, and then next weekend we'll start on the OpenGL stuff that we need to do in terms of putting in some shader code and multi-sample anti-aliasing resolves so that we can clean up the artifacts that we have in there, like the sort problem and the fringy, blinky edge stuff, which needs to get taken care of. So, hope you'll join me for those. That's about it. Until tomorrow, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.